Integral as a net change, AP questions. Objectives. By the end of this lesson, you should be able to set up and solve AP net change problems, find and store functions and points of intersection in the graphing calculator, and evaluate integrals involved in net change problems on the graphing calculator. Alright, let's jump into our first AP question. Traffic flow is defined as the rate at which cars pass through an intersection, measured in cars per minute. The traffic flow at a particular intersection is modeled by the function f, defined by f of t equals 82 plus 4 sine of t divided by 2 for times t between 0 and 30. And f of t is measured in cars per minute, and t is measured in minutes. So before we look at the 4 parts of the question we're being asked to answer, let's try to understand this function that I've been given. This function that I've been given represents a rate. It represents a derivative. Even though this notation doesn't have the prime notation or d something dt, this is still a rate of change because of the units of measure are in cars per minute. So if I were to substitute a time, t, in minutes into this t, or into this t in other words, what units would come out are in cars per minute. So just substituting in something like 1 right here, f of 1. So I'd substitute a 1 right here into this t. So 82 plus 4 sine of 1/2 is a numerical value. That numerical value is in cars per minute. So it means that at exactly 1 minute, there are that number of cars per minute passing through that specific intersection, so a particular intersection. So just substituting in values into this t will give me out units in cars per minute. So now let's take a look at the first question. To the nearest whole number, how many cars pass through the intersection over the 30-minute period? So let's go again. To the nearest whole number, how many cars? So my answer has to be in a unit of cars. How many cars pass through the intersection over the entire 30-minute period? So the first thing I want to clarify is we are not just substituting in the number I see here, 30, into the function. So the best way to answer a lot of these questions is to truly understand the units. If I were to just substitute 30 into f of t, my answer would be in cars per minute. But we just agreed I want to know how many cars. So that means that in calculus we have two options. We're either going to take the derivative or we're going to evaluate an integral. Now in this case, I want to evaluate an integral. I want to get to just cars. If I were to take a derivative in cars per minute, my answer would be cars per minute, or cars per minute squared if I took the derivative of f of t. But instead, I'm going to evaluate an integral. Now, again, to help us understand the concept of units, let's say we were to graph this function f of t. So for now, let's assume I don't know exactly what it looks like. This is just my function f of t. Now, the units of my function, which means the units on the vertical axis we've said a couple times now, are cars per minute, and the units of my horizontal axis, time, is in minutes. So finding the area under the curve during the first 30 minutes, so from 0 to 30, the area is going to be the units of the base times the units of the height. So cars per minute times minutes, cars per minute times minutes, well, the units that are going to cancel are minutes, and my answer will be in cars. So understanding the units is really going to help us evaluate this first part of the problem. So part A, I'm going to have to set up the integral from t equals 0 to t equals 30. So I wanted to know how many cars pass through over the 30-minute period. So starting at time 0, ending at time 30, of the function f of t dt. Now, since the function has been given to us in the problem, 82 plus 4 sine of t over 2, there's no need to rewrite it. So we're talking about AP problems now, and we want to save ourselves some time. What we do have to write down is the setup of the integral. So this right here is absolutely required. So the integral from 0 to 30 of big F of t dt. So let's talk about a couple of things now. I want to make sure that I write big F of t dt, so I don't want to start changing things to little f. There is no little f. There is no x's involved, so I want to be sure to recall the function that is being used in the problem. And now I need the numerical answer. So to find the numerical answer, this particular problem is a graphing calculator problem. So off to the left here you see a TI-84 graphing calculator. So let's go ahead and go over how we would enter this into our graphing calculator. Now, this one function is going to be used throughout the entire problem. We're probably going to have to use it more than once in our calculator, so we're going to go ahead and store it and enter it as y equals. So we can go ahead and turn the calculator on, go to y equals, and enter our function. And you'll see I've already gone ahead and done that. So 82 plus 4 sine of course, x over 2, because we don't have the variable t, but x will do. So here is my function. Now, something else we should troubleshoot right now is that we want to make sure that our calculator is in radian mode. So clicking mode, it is highlighted as radian mode because that will completely make our answer wrong otherwise. So y1 is right there in our calculator. So let's go back to the home screen. So second quit. And now we're evaluating this integral here. So we're going to go ahead and go to math, and we go to math 9. And our lower limit of integration is 0. Our upper limit of integration is 30. And to avoid entering that function in over and over again, we stored it as y1. So we're going to go to vars, go right 1 to yvars. We can hit 1 or enter for function, and then enter again for y1. And then we'll fill in the variable in our differential as an x. And then we can go ahead and hit enter. So the numerical answer is 2,474, and it says to the nearest whole number. So if this was not here, we would definitely go to the thousandths place, but because to the nearest whole number, our answer is 2,474 cars. So we wouldn't want to think of a fraction of a car. So let's go ahead and fill in our answer. So 2,474 cars is our numerical answer. So this is what we would need to write in order to obtain full credit on this problem. We'd have to set up the integral, but again, there's no need to write out the whole function. So 82 plus 4 sine t over 2, we can just call it what it was named, big F of t. And then we do have to write our numerical answer. And again, we were told to the nearest whole number, so no need to round or truncate to the thousandths place. Alright, so now let's move on to part B. Part B is asking, is the traffic flow increasing or decreasing at time t equals 7? Give a reason for your answer. So here is the traffic flow. Well, traffic flow had a name or a function. The function is called f of t. So here they've written it out in words. Is the traffic flow increasing or decreasing? But traffic flow is really can be thought of as f of t. So this problem is asking us, is the function, is f of t increasing or decreasing at time t equals 7? So now this takes us back to remembering that a function is increasing when its derivative is positive. So we're looking at the specific value right here at t equals 7. So for part B, we need to determine the sign, positive or negative, of f prime of 7. So is the traffic flow, which was called the function f of t, is f of t increasing or decreasing at time 7? We're really asking ourselves, is the derivative positive or negative at time t equals 7? And because this is a graphing calculator problem, again, we can do this on the calculator, and we've already stored the function big F as y1. So now we're doing a derivative, a numerical derivative. We can go to math 8, and our variable is x, and we want to go to vars over to yvars, enter, and use y1 again. And we're evaluating this particular function at a specific value at 7. So since the answer is negative 1.7829, we know that f prime of 7 is a negative value, so if the derivative is negative at a particular value, the original function is decreasing. So we can say f prime of 7 equals negative 1.872, which is less than 0. So there is my reason. So f is decreasing. Or we could replace f with traffic flow, as that is what the function f represented, and that was the way that the problem was worded. So we'd probably want to put, so the traffic flow is decreasing. So we answered parts A and B of this question, and we'll hold off in a later lesson to go over parts C and D. Alright, let's jump into another AP question. Water is pumped into an underground tank at a constant rate of 8 gallons per minute. Water leaks out of the tank at a rate of radical t plus 1 gallons per minute for times t between 0 and 120 minutes. At time 0, the tank contains 30 gallons of water. So this last sentence meaning at the beginning, the tank already had 30 gallons of water in it. So let's go back and try to visualize what's happening. We have this underground tank that water is being pumped into constantly at this rate of 8 gallons per minute. So what I've just been given here is a function. So I'm going to go ahead and call it f of t. So the variable is t, and it's a constant function. So f of t is 8, and the units are gallons per minute. So in other words, it doesn't matter what time I plug in here. If I plug in the number 1, I still get 8 gallons per minute. So what that means is after 1 minute has passed, water is still pouring in at this constant rate of 8 gallons per minute. After 30 minutes have passed, it doesn't matter. Water is still pouring in at a steady rate. So imagine a faucet. So let's try to, again, visualize what's happening here. So let's say I have this tank, and I don't know, here's a faucet, and we have water coming in. So water is just constantly coming in at this rate of 8 gallons every single minute. And at the same time, water leaks out of the tank at a rate of radical t plus 1 gallons per minute. So that's a separate function. I'm going to call g of t, the other function, radical t plus 1, also in gallons per minute. So at the same time water's coming in, water's also leaking out. So let's imagine that there's a hole in the tank that's, I don't know, since it's not coming out at the same rate, maybe that hole is expanding. So water's coming out at different rates every single minute. So after 1 minute has passed, water is coming out at a rate of radical 2, because 1 plus 1 is 2, so radical 2. But after 10 minutes has passed, water is coming out at a rate of radical 11 now, because 10 plus 1 is 11. So let's say that hole in the bottom is expanding as time goes on. So that's why more and more water is leaking out, but the faucet that's pouring it in, nothing's wrong with that. So it's coming out at a constant rate every time. And at the very beginning, there was already 30 gallons in the tank. So let's say it already had some water inside of it. So now hopefully we have a good understanding of what's going on. So now let's try to answer the question. Let's start with part A. How many gallons of water leak out of the tank from time t equals 0 to t equals 3 minutes? Alright, so for part A, I'm being asked specifically about how many gallons leak out of the tank. So f of t was the going in function. So let me go ahead and label these. F of t was the water pouring in, and g of t was the water coming out. So just so we remember that. So for this first part of the problem, I'm only being asked to consider the function g of t, because g of t is the water pouring out, or the water leaking out function. So I'm not concerning myself with f of t at all. Nor am I concerning myself with this quantity that at time 0 there was 30 gallons in the tank. We're not being asked anything about that fact. I just want to know how many gallons of water leak out of the tank between 0 and 3 minutes. So I have two times here. I have t equals 0 and t equals 3, and those are going to be the limits of integration because I need to set up an integral for part A. For part A, I'm setting up the integral from t equals 0 to t equals 3 of my water coming out function, which is radical t plus 1 dt. So how do we know to set up an integral and maybe not find a derivative? Or maybe just substitute in these values, 0 and 3, into the function? Well, the answer is because of units. So if I were to just substitute, let's say 0 and 3, or let's just take 3, into this g of t function, plugging in a 3 here for this t and into this t, my units would be in gallons per minute. So I'd get 3 plus 1 underneath the radical, so 2 gallons per minute. But looking back at the problem, I wanted to know how many gallons of water leak out. So again, taking a derivative, the units wouldn't be correct. If I took a derivative of g, I'd get gallons per minute squared. So I need to integrate, and again, if you need to go back to this, that's fine. So g of t is some function, and the units of g of t on the vertical axis are in gallons per minute. The units on the t-axis are in minutes, so finding area under the curve, which represents a definite integral, the area of the base would be minutes, the area of the height would be gallons per minute, so gallons per minute times minutes, the minutes cancel, and we end up with just gallons. So that's how we know we're setting up an integral. So this particular integral is not a graphing calculator problem. In fact, it can be solved using U substitution. So this is a non-calculator problem all in general. So no parts of this problem are graphing calculator on the AP exam. So in our U substitution, we would let U be t plus 1. So du is dt. And our limits of integration would change because this is a definite integral. So if I substitute in 0, u of 0 is 0 plus 1, so that's 0. So my new limit would be u equals 1. And then u of 3 would become 3 plus 1, so that would give me 4. So my u equals 4. And t plus 1 becomes u. And dt becomes du. So now I don't have to care at all about this integral. I'm solving this definite integral here. So this definite integral, I'll drop the u's and the limits, goes from 1 to 4 of u to the 1/2 du. So now I find the antiderivative of u to the 1/2, so u to the 3/2 times 2/3, and then I substitute in 1 and 4. So if I substitute in 4, I get 2/3 4 to the 3/2 minus 2/3 1 to the 3/2. And now let's look back at the problem. How many gallons of water leak out of the tank between 0 and 3 minutes? This right here, as ugly and messy as it is a numerical answer. So we can stop right there and say this many, whatever this exact number is, gallons, leaks out of the tank between 0 and 3 minutes. So we should stop here at the risk of simplifying incorrectly and then losing points. We should stop here and box in our answer. So this many gallons leaks out of the tank between 0 and 3 minutes. So this is the soonest I can stop. I cannot stop right here at this step because my answer is not a number yet. But once I substitute in my limits of integration, I can go ahead and stop and say this is the answer. Alright, let's move on to part B. How many gallons of water are in the tank at time t equals 3 minutes? Alright, so this question, how many gallons of water are in the tank at time t equals 3 minutes? So this one is sort of a tricky one. Well, at the start, there were 30 gallons of water in the tank. So now we have to take that into consideration because we want to know how many gallons are in the tank at 3 minutes, and that depends on how many there were to begin with. So for part B, we're going to go ahead and start with the fact that there were 30 gallons in the tank to begin with. But then I have to consider, well, how many gallons have entered the tank during that time frame of the first 3 minutes? And then I have to think about, well, how many gallons leaked out of the tank during the first 3 minutes to figure out the total number of gallons that were in the tank at 3 minutes. So how many we had to begin with, 30, and then I need to add how many entered the tank between 0 and 3 minutes, and then I'm going to need to subtract how many leaked out of the tank during the first 3 minutes. So just to write ourselves some notes, I mean, we wouldn't have to write this on the AP exam. So to begin with, and then how many went in, and then how many gallons went out or leaked out. That's ultimately the setup that we're going to need to figure out. So how many gallons went in between 0 and 3 minutes, and then how many gallons went out between 0 and 3 minutes. Now, hopefully you're thinking, well, I know how many leaked out. I already found that in part A. And that's true. We absolutely did already find that numerical answer. So we can just copy that numerical answer from the previous problem. So that's eventually what we're going to fill in here. So now it's just a matter of figuring out how many went in. So the going in function was f of t. And so we can do the same setup to figure out how many went in. So I'm going to go ahead and put that off to the side. I can find the integral from t equals 0 to t equals 3 of the function, the going in function, 8 dt. So the antiderivative of 8 is 8t from 0 to 3. And then we'd substitute in 3, so 8 times 3 minus 8 times 0 is exactly 24. So 24 gallons went into the tank during the first 3 minutes. And maybe some of you were thinking, well, I didn't really have to evaluate this integral. If this is just a constant, well, after 1 minute has passed, 8 gallons poured in, if this is in gallons per minute, and after 2 minutes have passed, well then 8 times 2, 16 gallons must be in there. So after 3 gallons have passed, or 3 minutes have passed, there must be 8 times 3, so 24 gallons in there after 3 minutes have passed. So if you could have understood that based on the fact that the water coming in was constant, you didn't have to show this work for the integral. But setting up this integral is perfectly fine. And definitely shows a conceptual understanding. So for the numerical answer, we would want to go ahead and take 24, over, so this is how many went in, minus how many leaked out, so we would take our previous answer. And if we're not going to simplify it, we want to make sure and keep it inside parentheses, because since we're subtracting it, that's definitely going to make a difference. So it was 2/3 4 to the 3/2 minus 2/3 1 to the 3/2. So again, this is a numerical answer, so we can leave our answer like this. So there was 30 plus 24, and then minus however many leaked out. So the amount we started with plus how much went in minus how much came out. So that is our answer to part B. Alright, so now moving on to part C. Write an expression for A of t, the total number of gallons of water in the tank at time t. So part C is asking us to generalize what we did in part B. Part B asked us to find specifically how many gallons were in the tank after 3 minutes. But part C is asking us to write an expression for A of t, the total number of gallons in the tank at some generic time t. So let's go ahead and start. Part C is going to be A of t is going to have to equal, so we're about to write out a function. And writing out part B like this should help us write the function A of t. So to find the total number of gallons at some generic time t, well, it still matters how many gallons there were to begin with, so that's not going to change. I'm still going to need to start with the fact that there were 30 gallons in the tank, and I'm going to need to add however many gallons went in, but instead of between 0 and 3 this time, it's going to be between 0 and t. So my integral is going to go from 0 to t of the function 8. So over here, doing this work actually would help us set up part C a little bit easier. So originally I went from time 0 to time 3 of the function 8. So now I want to go from time 0 to some generic time t of the function 8. And now here's where I need to be a little careful. So notice I didn't write my limits of integration as t equals, because that wouldn't quite make sense to say from t equals 0 to t equals t of 8 dt. So in fact what I need is a dummy variable for my differential, so I'm just going to go ahead and call that x, because this is a of t, a function of t. So when I substitute in a number right here, I want that number to only be replacing this limit of integration up here. So I don't want it to have to do with the actual integrand or the differential. So I think maybe it'll be a little clearer in the next part. So this is how much water came in between 0 and t, and I need to subtract how much water fell out between 0 and t. So the leaking out function is this function here, g of t, which is radical t plus 1. So again, I don't want to put in that variable t, because that variable t corresponds to this a of t function that we're trying to write. So I'm going to call the dummy variable here x plus 1 dx. So let's try to think about it. We can make sure that our a of t function works by looking back at part B. So I should be able to substitute in a 3 right here and get the same answer I got in part B to tell me the total number of gallons at time 3. So plugging in a 3 right here for t means I'd plug in a 3 right here for t. So the integral from 0 to 3 of 8 would give me 24, just like it did over here. And then the integral from 0 to 3 of this function, radical x plus 1 dx, and it would give me the same value that I got from part A, this numerical value here. So again, I wouldn't want to put a t right here, because then it would look like I should take that 3 and put it right here, when that's not the case. The 3 is just the upper limit of integration, or the generic t. So this here is my expanded answer for the expression of a of t. Alright, and now the last part, part D. At what time t, where t is between 0 and 20, and note that this is a closed interval, we have less than or equal to, less than or equal to, is the amount of water in the tank a maximum? So at what time t is the amount of water in the tank a maximum? So let's look at this a of t function from the previous part, from part C. The amount of water in the tank at any time t is given by this function. So the units of this function are in gallons. So if I were to plug in again, so that number 3, into this function, I would get a numerical value, and that value would be the number of gallons in the tank after 3 minutes have passed. So this a of t is the amount of water in the tank. So I'll abbreviate that, the amount of water, H2O. So that's what this a of t represents. So at what time t is the amount of water in the tank? This whole thing right here is a of t. So this question is asking us, at what time t does a of t have a maximum? So to find a maximum value of a function on a closed interval, I have to check the endpoints and the critical points. So in other words, I am going to need a of 0, I'm going to need a of 120, and then I'm also going to need a of the critical points. So I'm going to need to find all of these values. So the way to find critical points is to set the derivative equal to 0 or undefined. So I have to find the derivative. I need a prime of t. And to find a prime of t, we're using the FTC part 2, because each of these portions here are accumulation functions. So the derivative of 30, well, that's 0. If I take the derivative of this function here with respect to t, because I'm finding a prime of t, so imagine like slipping in a little ddt right here. Since this is t and this is t, so remember what happens, we take this variable and we substitute it into the x that's here, but there is no x. So the derivative of this would just be 8, because there is no t to plug it into, so it would just be the function 8. So 8 is the derivative of this accumulation function. And now I have to take the derivative of this one. So imagine again sneaking a little ddt in here. So the t's match. This t goes into this x. So it would be minus the square root of t plus 1. So a prime of t is 8 minus the square root of t plus 1. So now I need to set that equal to 0. So 8 minus radical t plus 1 equals 0. So if we subtract the 8 and then divide by the negative, so both of these become positive. So in order to get rid of the radical, I'm going to square both sides. So I'm going to get t plus 1 equals 64. So I'm squaring both sides now. And so if I subtract the 1, t equals 63. And the units of this are going to be in minutes because it's a t, a time, and my time is in minutes. So in other words, I also need to check a of 63. So now it's a matter of substituting in these numbers into this a of t function and then determining what is the biggest value. So a of 0 is going to be 30 plus the integral from 0 to 0 of 8 dx minus the integral from 0 to 0 of radical x plus 1 dx. So that one's nice. 0 to 0, 0 to 0. These two integrals are 0, so the answer is 30 gallons. And then we need to substitute in a of 120 and a of 63. So we have 30 and then the integral from 0 to 120 of 8 dx, and then minus the integral from 0 to 120 of radical x plus 1 dx. And then we're going to have to do 30 plus the integral from 0 to 63 of 8 dx minus the integral from 0 to 63 of radical x plus 1 dx. Alright, so let's go ahead and see how this is going to turn out. I'm going to have to make some space, so I'm going to erase this. Alright, so this part would be, let's see, 30 plus, I'm doing a little bit of stuff quickly here. So this would be, the antiderivative is 8t, so when I substitute in 120 and then 0, it's just going to be 8 times 120. And we actually did this antiderivative earlier. It required a u substitution. And what ended up happening, so again, I'm doing some shortcuts. This was 2/3, and my new limit of integration, if I let u be x plus 1 to this 120, would be 121. So this is 121 to the 3/2 minus 2/3 1 to the 3/2. And then here, this would be 30 plus 8 times 63 minus, and then we have 2/3, 63 would become 64 to the 3/2, and then minus 2/3 1 to the 3/2. So we have to figure out what's biggest. Alright, so a lot of algebra later, we would determine that this is the largest number, so this is the amount of water in the tank that is a maximum, but then we have to be really careful. It says at what time t is the amount of water in the tank a maximum. So this was the biggest output value, but the answer is the time. So when did that happen? At 63 minutes. So that would be our answer. At 63 minutes, the amount of water was a max. So the justification is the work in showing how to find absolute maximums. And so, clearly part D is a lot more work, and oftentimes the latter parts of the problem are the ones that are going to be a little bit trickier than the previous parts. But they're trying to get you to see that you could use the integration that you used from part A with a little bit of tweaking, and then this would be some simplifying. So I'd have to do the square root of 121, which is 11 cubed, and multiply that by 2/3, so we could see that this is actually a pretty big number when subtracted from 960, and that's why this one ends up being the bigger one. So a little bit of simplifying. You don't need to get it down to an exact whole number or a final answer, but it's justifying to yourself which one is bigger. So it's definitely between the second two, as opposed to a of 0, which is just 30. So once you decided which one it was, then the answer is either 120 minutes or 63 minutes. It's the time. At what time t.